Got it. Yes. So yeah. So that's all about the exam structure and all. Right now, we are going to see about the number systems and codes. Right. Hope most of you have came across these topics earlier. We are going to see a bit more in detail today. Right. Right. So you can see the lecture notes which is uploaded in Google Classroom, right? This one is uploaded in Google Classroom. First of all, yeah, we have an introduction about our decimal number system, right? Decimal number system. Decimal means it's about 10, right? Base 10 number system, right? So we have digits from 0 to 9. So every number is made up of digits from 0 to 9, right? And then that decimal point separates the plus power and minus power, right? So in this side of your decimal point, you have plus powers. For example, if it is 654, then 4 stands for 10 to the power 0, and 5 stands for 10 to the power 1, and the 6 stands for 10 to the power 2. Similarly, from your left hand side of the decimal point, that becomes 10 to the power minus 1, minus 2, and minus 3, something like this, right? So yeah, so that's your decimal number system, right? But we are using day by day, and we have studied a lot about these decimal numbers. Let's see something about the binary number system, right? Binary number system is an interesting number system because it has a base of 2, right? Decimal number system have a base of 10, hence it has 10 digits from 0 to 9, right? Binary number system have a base of 2, and hence it has only 2 digits, which are 0 and 1, right? So yes. Yes, right? So now let's see about the binary numbers. Right, binary numbers are, as I said earlier, base of 2, right? So we have only 2 numbers or 2 digits, right? So any number should be represented by both 0 and 1. Why we are using binary numbers in digital electronics or electronics is similarly it has 2 states, right? 0, we can assume 0 as one state and 1 as the other state, right? So only 2 states is enough or sufficient to represent the whole number system, right? First of all, let's see how we can convert a decimal number into, a decimal number into a binary number, right? So it's easy, as you've seen earlier. I don't want to waste a lot of time on it, right? For example, consider number 30, right? 30 decimal. Since it is decimal, we never use the base here, right? If we want to convert it into binary number, what we need to do is we need to perform a successive division, right, by 2. So I can divide by 2, this becomes 15, and I have 0 as my reminder, right? Again, I can divide this by 2. So I have 7 into 4, 7 into 2, 14 plus 1, right? So 7 times and 1 reminder. By 2, I could say 3 times and 1 reminder. By 2, I can write it as 1 time and 1 reminder. Am I right? So again, if I do by 2, I can divide it as 0 times and 1 reminder. Right? If you want to convert a number into a binary number, you should divide that until you have 0. Right? Until you have 0, and then write the number from bottom to top. So your number, equivalent number, will be 1 1 1 1 0 binary, right? This binary is very important, right? If you don't use any base, it means that the number is a decimal number, right? Without this one, this is just like 11,110, right? But with this binary only, it make that 11110 binary, right? You should call you should read it as 11110 binary, right? Now let's see how we can convert this binary number into a decimal number. As I said earlier, each number have a value for its point, right? Value for its place. For example, this represent 2 to the power 0, and this one 2 to the power 1. This is 2 to the power 2, and this one 2 to the power 3, and this one 2 to the power 4. Right? So I could rewrite this number as 2 to the power 4 means 16, right? 2, 4, 8, 16. So I can write it as 16 into, I have 1 at 16's place, right? So plus, here again 2 to the power 3 becomes 8 into 1 at its place, right? Plus, right, 2 to the power 2 becomes 4 and 1 at its place. Plus 2 to the power 1 becomes 2 and 1 at its place. Plus 2 to the power 0 becomes 1 and 0 at its place. Clear? So if I rewrite this one, so 16 plus 8 plus 4 plus 2. 16 plus 8, 24, 28 and 30. Right? So this is how converting a decimal number into binary number and then binary number into decimal number. Right? So now let's see how we can perform the same thing for a fractional number, right? For fractions. Right? For example, consider, okay, 0.3125. Right? 0.3125. Sorry. Right? So for fractional numbers, what we need to do is we need to perform successive multiplication. Here we did successive division, and for decimal point numbers, we are going to use successive multiplication, right? For example, if it is 0.3125, we need to multiply that one by 2, right? I will get, if I 3125 means, if I multiply that by 2, I will get it as 0.625. Am I right? 0.625, right? I could see here, look at this one, right? I could write this one, right? Before the or carry, I can write it as 0. I have 0 here. Am I right? So that 0 comes here. And then again, I have to write this one here, right? 0.625, and then I need to multiply that by 2. That becomes 1.25. Am I right? So here I have 1. Right? I have 1. Now remove that 1 because I wrote it there. So this becomes 0.25. I have to write that one here, right? 0.25 into 2, which becomes 0.5. So here I have 0. So again, I will write it as 0. Now I need to multiply that by 2, right? So 0 becomes 0.5 into 2, which is equal to 1.0. If I put 1 there, I have 0 left. Am I right? I have 0 left. If you want to convert a decimal or a fractional number into a binary number, you need to perform successive multiplication until you get 0. Right? So I can say that I have 0.0. You need to divide it until you get 0. Right? And then you need to write the number from top to bottom. Here you brought it from bottom to top, and then here you have to write it in this way, right? So the number will be 0.0101 binary. right? 0.0101 binary. Now, let's see how we can convert this number into decimal number, right? For example, this is 2 to the power minus 1. Am I right? This one, 2 to the power minus 2. This one, 2 to the power minus 3. This one, 2 to the power minus 4. 2 to the power minus 1 means 1 over 2. Am I right? 2 to the power minus 2 means 1 by 4. 2 to the power minus 3 becomes 1 by 8 and minus 4 becomes 1 by 16. Right? So I can write it as 1 by 2 into 0 at its place. Am I right? Plus 1 by 4 into 1 at its place. Right? So I have 1. Again, plus 1 by 8 into 0 at its place. Then plus 1 by 16 into 1 at its place. That's all, right? So this one 0, this one 0. So I have 1 by 4 plus 1 by 16, right? Which is 1 over 4 plus 1 over 16, which is 5 by 16. Am I right? 4 by 16 and 5 by 16. And if you simplify it, you will have 0.3125, right? So this is how converting a fractional number into decimal number, right? For some numbers, right? For few numbers, you cannot do that until you get 0, right? It will continue, keep on continuing, right? For that, what you can do is you can stop with the 4th digit or 5th digit, right? Because it is not going to make any sense by continuing that one, right? For example, something like 0.33 or whatever, right? So you cannot go until 0, right? It will keep on going, right? So in those numbers, you can stop at a certain point with 5 bits or 6 bits, right? It's your choice. So if it is asked in the question, you can stop with that, right? So yeah, that's all about the binary basics. And now let's see how we can do binary addition and binary subtraction, right? Oh yeah, right. For example, as I said earlier, it's a 2-bit number, right? So I can in a single stage, I can perform only 3 different combinations of addition, right? It could be either 0 plus 0, 0 plus 1, or 1 plus 1. Am I right? Right, 0 plus 0 is 0, as we all know, right? 0 plus 1 is 1, as we all know. Again, 1 plus 1, here comes the problem, right? So 1 plus 1 is actually 2 in decimal number system, right? Even in binary number system, so 2 becomes 1, 0, right? So 1 plus 1 becomes 1, 0. So we will put 0 there, and then the 1 becomes carry to the next level. That will be conveyed to the next stage, right? So 1 plus 1 becomes 1, 0. Similarly, if it is 1 plus 1 plus 1, then that becomes 1, 1. So 1 is your sum and the 1 will be your carry, right? Now, let's see a couple of examples, right? Just a brief examples, right? For example, 1, 0, 1, 1, 1 plus 1, 1, 1, 1 plus. So both binary, right? Binary, binary. Remember, this binary is very important, right? Without that one, of course, I need to put all binary there. It doesn't make any sense, right? So as I said earlier, 1 plus 1 is 1, 0. Am I right? I can put 0 and 1 will go as the carry to the next level. Now this becomes 1 plus 1 plus 1, which is 1, 1. I will put 1 as the sum and 1 will go as the carry to the next level. Again, 1 plus 1 plus 1, which is 1, 1. So 1 will go here and the other one will go to the carry as the carry to the next level. So now 1 plus 0 plus 1, which is 1, 0. So I will put 0 here and then 1 as the carry to the next level. Now 1 plus 1 becomes 0, 1. Binary. Right? So this is how performing binary addition. Similarly, binary subtraction, right? Which is also the same. For example, 1 0 0 0 subtract, okay, 1 1, binary, and then you need to perform subtraction, right? You need to perform subtraction. As I said earlier, 1 minus 1 is 0. Now here comes 0 minus 1, right? We cannot perform the subtraction. What we need to do is we need to borrow a 1 from your previous stage, right? So in your decimal number system, whenever you are borrowing from your previous stage, that becomes 10 to the next level. Am I right? That becomes 10 to the next level. But since it is base 2, it will become 2 as the next level, right? So you cannot borrow 1 from this 0 or this 0. So you can borrow this 1 only, right? So that will be removed, right? This becomes 0. And when you borrow this 1 to the next level, this becomes 2, right? And then now you can borrow 1 out of these 2. So 1 will be there and the remaining 1 will go as 2 to the next level. Now again you need to borrow 1 to the next level, right? So that 1 will be there and that remaining 1 will go as 2 to the next level, right? So now 2 minus 1 is 1, right? Again 1 minus 1 is 0, 1 0 will be 1, this 0 will be 0, final. Clear? So this is binary subtraction. Similarly, you can perform multiplication and division as well, right? You just refer the lecture notes, which is really simple, right? Which is clearly explained in the lecture notes, right? Now, let's see, we have another number system, right? Okay, this is binary. Let's see about octal number system. Right? Octal numbers or octal number system. Right? As we seen earlier, for binary numbers, the base is 2, and for octal number system, the base is 8. Right? So we have 8 digits which are 0, 1, 2, 3, 4, 5, 6, and 7. Right? We don't have 8. To represent 8, we will use 1, 0. Right? 1, 0. The procedure is same. For example, if you want to convert 125 into octal number, you have to divide by successive division by 8. Right? If you divide 120 by 8, so that becomes, what is that, 15, no? 15, 8, 15 into 8, 120, and then 5 is my remainder. If I divide by 8, then that becomes 1, and 7 is my remainder, and so I can write it as, if I divide that by 8, so 0 and 1 is my remainder, right? So I have to write it from bottom to top. So number is 175 OCT, or octal, right? This is really important. Now again, let me do the opposite direction, right? This be 8 to the power 0 now, right? Not 2 anymore. Since it is octal number system, this is 8 to the power 0, 8 to the power 1, and 8 to the power 2. What is 8 to the power 2? Will be 64. 64 into 1 at its place, right? And then plus 8 to the power 8 becomes 8 into 7 at its place, plus, right, 8 to the power 0 is 1 into 5 at its place. So I can write it as 64 plus 56 plus 5. 64, 56, 120 plus 5 becomes 125. Right? 125 decimal. Right? The rest of the things also the same. Right now, what we can do is we can do a special conversion here. When we are converting octal number to binary numbers, for example, if we want to convert 175 into octal, sorry, binary number, right? OCT to binary, since 8 is equal to 2 to the power 3, what I can do is I can simply represent each digit into a 3-bit binary number, right? 3-bit binary number. For example, 0, 0, 0, 0, 1, 0, 0, 1, 2, 3, 4, sorry, 5, 6, 7. So I can write it as 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Am I right? So this is the sequence, right? Or if you want to write it this way, this in the order, I could give you a shortcut, right? See here. 0, 1, 0, 1, 0, 1, 0, 1. Am I right? Go to the next step. Right? So this is, what is this one? Yeah, 0, 0, 1, 1, 0, 0, 1, 1. And then go to the next level. That becomes 0, 0, 0, 0, 1, 1, 1, 1. Right here, 1 by 1, 2 by 2, 4 by 4. And if you have hexadecimal number, that will be 8 by 8. 8 zeros and 8 ones. So writing a sequence of binary number is simple. Okay. Right. For example, if you want to convert 175 octal into binary number, 175 into binary number, I can simply write it as, okay, 1 is 0, 0, 1. Am I right? Equivalent number is 0, 0, 1. 7 is 1, 1, 1. And 5 is 1, 0, 1. Remember, the zeros in front can be removed, but this is really important whenever they are coming in the middle or at the end. For example, OCT, 1117 OCT. Let's see how we can write this one, right? So I have to divide them into 4 numbers. Each digit has to be represented by a 3-bit equivalent number. So this becomes 0, 0, 1. Again, the other one 0, 0, 1. Another one 0, 0, 1. And this one becomes 1, 1, 1. Right? So these 2 zeros, you can neglect them, but not other zeros. Right? So that will be binary. Simple. If you want to convert a binary number into octal number, is also the simple, right? For example, okay, forget about all the other things. Let's put 1 here, right? So this is a number. My question is, convert this number into octal number. What you have to do is divide them into 3 numbers, 3 bits, right, from your right hand side. And then, yeah, I have only 1 left. Just add any zeros, any number of zeros in front of it to match it with 3 bits. Now look at this one. Yes. So what I can do, substitute each numbers with the equivalent values. 0, 0, 1, which is 1, 0, 0, 1, again 1, 0, 0, 1, 1, 0, 0, 1, 1, 1, 1, 1, which is 7. I could write it as 1, 1, 1, 1, 7 OCT. Clear. So this is about octal number system, which is really simple. Now let's see about hexadecimal number system. Again, hexadecimal. Right, hexadecimal means the base is 16. Right, base is 16. Right, so we use numbers like 16 means we need 15 digits. Am I right? To represent a hexadecimal number system, we need 15 digits. So we can start from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and instead of A we use capital, sorry, 10 we use capital A, B for 11, C for 12, D for 13, E for 14, and capital F for 15. Clear? E for 14 and capital F for 15. Similarly, since 16 is 2 to the power 4, right? 16 is 2 to the power 4. We can use 4-digit numbers, right? 4-digit binary numbers to represent a single hexadecimal number. This becomes 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0. 0, 0, 1, 1. Look at here, right? 4 zeros, and then I have to be 1, 0, 1, 0 alternating, 0, 0, 1, 1, right? So I'll put something like that, right? Okay. Maybe I don't know. I will be getting confused. 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. Similarly, this is 0, 0, 1, 1 means 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1. Clear, right? Again, at the front, I need to have 4 zeros and 4 ones, right? 0, 0, 0, 0, 1, 1, 1, 1. 0, 0, 0, 0, 1, 1, 1, 1. Right here, 8 zeros and 8 ones. So 4, 5, 6, 7, 8, and then 1, 1, 1, 1, 1, 1, 1, 1. Look at this one. All are filled. Right? The complete table is filled. Now, I have a hexadecimal number, for example, 17AF hex. Right? I have 17AF hex. Right? My question is, convert this one into binary number. Octal number, what we have done is, it is base 8 and 2 to the power 3. Similarly, hexadecimal is 16, which is 2 to the power 4. What we can do is, we can represent each digit with a 4-bit binary number or a 4-digit binary number. So 1 is equivalent to 0, 0, 0, 1. 7 is 0, 1, 1, 1. A is, look at here, A is 1, 0, 1, 0. F is similarly 1, 1, 1, 1. 1, 1, 1, 1, binary. Right. Similarly, for example, forget about this one. And if you want to convert this binary number, right? For example, I'll put one more 1, 1, 1 in front of it, right? And then another 0 at the end. What I need to do is I need to divide that into, right, space of 4. Right? So 1, 2, 3, 4. Again 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Luckily, I have 4. If it is 3, I need to put a 0 in front. Right now, look at here. 1, 1, 1, 0. Go through the figure, and then 1, 1, 1, 0 is E. Am I right? 1, 1, 1, 0 becomes E. Right? Again, 0, 1, 0, 1. 0, 1, 0, 1, which is 5. 1, 1, 1, 1, which is F. 0, 0, 1, 0, 2. 1, 1, 1, 0 is E again. So I can write my number as E, 2, F, 5, E, hex. Right? So hexagonal to binary and binary to hexagonal is simple because only due to, because 16 I can write it as 2 to the power 4 and 8 of octal of course, I can write 8 as 2 to the power 3. That's why we are grouping into 3, and here we are grouping into 4. Okay, right. So right. So that's all about number systems. Right now, we'll see about codes. Codes. Right. The main difference between number systems and code is codes. Right. For a number system, see here, I have E here and E here. Am I right? But the value of this E and this E is completely different. Am I right? So this becomes 16 to the power 0 into E, and this becomes 16 to the power 1, 2, 3, 4 into E. Right? So the value of a digit is depends on its position. Clear? If you have a number or in a number system, the position of the number plays or is matter, right? It's a big thing. But code, in a code system, it doesn't, right? The place or position of the number doesn't matter, right? For example, we have used that, you know, in our when you are at your school, right? We have done that, jumbling your names up with A with B and B with C. Do you remember? Maybe only for 90s kids, sorry, 80s kids, right? Those things. Okay, right? So those things are called as codes, right? So the first code what we can see here is a BCD code, right? A BCD code. Binary coded decimal, right? Coded decimal. Right? Binary coded decimal is actually, it is what we are doing is we are directly using a binary number. We are representing that with zeros and ones. Right? For example, 2056. Right? 2056, which is a decimal number. Right? What we can do is we can represent this one, right? This 6502 all with 4-bit binary number, right? 4-bit binary number. But remember, if you convert that one back into a decimal number, it is not going to give you the same value. For example, see here, we had a table aside, right? Forget about the things below 9, right? Because in a binary coded decimal, we are going to have only 9 digits because binary number system consists of 9 digits. Am I right? From 0 to 9. Okay, from 0 to 9. Hope you can see that one in the other side, right? If I want to convert 2056 into BCD, first I can do is 6, right? Represent that one. So 0, 1, sorry, 1, 0. Am I right? 0, 1, 1, 0 and 5, 0, 1, 0, 1. 0, again, I have to represent that by 4 zeros, right? 0 becomes 4 zeros. Again, 2 becomes 0, 0, 1, 0. So this is the equivalent BCD of 2056. Remember, this is just a code, right? This is just a code. If you want to convert that one back into a BCD number, sorry, a decimal number, you need to divide that by 4. You need to divide them by 4 and then you have to add. Remember, here in a BCD number systems, you cannot have any values below this one, right? These things cannot happen because in a binary coded decimal, you can have only until 1001. If you, while you are grouping, if you found 1010, that is not a BCD anymore, right? It is not a binary coded decimal, right? So what you can have is only up to 1001 when you are grouping it, right? If you have something else, then it means that the problem is completely wrong, right? So yeah, that's about BCD code, right? Each BCD number system. For example, if you want to represent 1, 6, right, 16 in B into BCD, what you have to do is you need to divide them into two, 1, 0, 0, 0, 1 and 6, 0, 1, 1, 0. I can remove these zeros in front of it, right? That doesn't make any sense. I can write it as 1, 0, 1, 1, 0, B, C, D. If I want to recalculate, I need to group them into 4. This is actually 0, 1, 1, 0, and then I need to add 3 zeros in front of it to make it 4 bits. Then this is 1, this is 6 back in here. Okay, so that's all about BCD to binary and BCD to decimal. If I want to make 16 into hexadecimal, that is just 1, 0 hex. Right? If I want to make 16 into decimal number system, then that becomes 2 to the power 4. So 1, 0, 0, 0, 0. 2 to the power 4 means I need to put 4 zeros. Clear, right? So this is the binary equivalent of 16. But when you write it as a BCD number, that becomes 10110. Right? This one and this one are not equal. Right? Remember, these things make sense when you are writing a number or code. Right? A number system or code. Right. Now we have another code which is called as the gray code. Gray code, right? GRAY code. A gray code. Right. For example, you have a binary number, right? So let 10110. Right? 10110 binary. This is very important. Right now, the question is to convert this into a gray code, right? So you need to convert a number into a code, right? So once you perform the conversion, it is not a number anymore. It is just a code, right? To convert this gray into binary, first thing what you have to do is the leftmost number, right? Which is the high value number, right? Just drop that one directly, right? So that one has to be added directly. And then, right? So this one directly put that one. Now add that number with the next number, and that becomes the second digit. So 1 plus 0 becomes, right? 1 plus 0 becomes 1. Now add that one with the next number, something like this. So 0 plus 1 becomes 1, and then add this one and this one. So 1 plus 1 becomes 0. Remember, if you have any carries, just forget about carry. Forget about carry. Just throw it away. Right? So that 1 plus 1 becomes 0. And finally, the last 2, 1 plus 0, which is 1. Right? So my equivalent 10110 binary is equivalent to 11101 gray. Right? 10110 gray. Right? Now let's see how we can convert the other way around. Right? From gray to binary. Now we have a gray number or a gray code, and let's see how we can convert that one into a binary number. Right? Gray code into binary number. For example, perform 11011, right? 11011. Right here, the same thing. Drop the first bit, right? Drop the first bit, and that becomes 1. Now this one and next one, add this one with this number, right? 1 plus 1 becomes 0. Forget about the carry, right? And now this 0 plus this one, right? Like this in a cross. So first drop this one, add this one, so that becomes 0. 0 plus 0 becomes 0. That 0 plus 1 becomes 1, and that 1 plus 1 becomes 1 again. Sorry, 1 plus 1 becomes 0 again. So I could say that 1 1 0 1 1 is equivalent to 1 0 0 1 0 binary. Right? 1001 binary. So these are the steps to convert a gray code into binary code, and then binary code into gray code. Right? If you couldn't pick it up through the video, don't worry about it, because the lecture notes is uploaded in the Google Classroom. Right? You can refer both. I will upload the video as well. Right? I will upload the recording as well, so you can refer the lecture notes along with the video. Definitely you can able to catch this one, right? So, and also yeah, I will upload a tutorial as well, right?